on down, okay? So he says, Brody says, a set of inputs and outputs where every input has a unique output. Is that basically what you said? Did I paraphrase that good enough for you? That's exactly what you said. Okay. A set of inputs and outputs where every input has a unique output. That's a terrible, terrible handwriting, by the way. Wow. Gosh, that's horrible. Sorry about that. Okay. Today in our lesson, we're starting chapter 6.1, or chapter 6. It's all about logarithmic functions and exponential functions. So I want to bring up the idea of what functions are again. All right, for the first box here, I'd like to talk about the inverse of a function. The inverse of a function. So I'm going to do this by a picture. So let's set up a domain and a range. So the domain is going to be Bob, Mike, and Sally. And my range is going to be $50, $10, and $35. Okay? So this is a function that relates my friends to how much money they have in their wallets. I'm going to be friends with Bob. Bob's going to buy my lunch. Kind of, I guess, right? Mike Ephraim's going to buy my lunch. That's right. Okay, so this represents my function f of x. Would you guys agree that this does indeed represent a function? Yes. Yes. Okay. What verifies that? Okay, every input has a unique output, right? Okay, good. No, go away. Okay, so if we say that this is a function here, right? My question to you is then, when you see the word inverse, what do you think about? Okay, yeah. Most people, when I say the word inverse, they think of the word opposite. So let me ask you a question. What is the opposite of 5? Negative 5, and you'd be correct. What is the inverse of 5? 1/5. So is there a difference between the word opposite and the word inverse? Yes, there is, right? When the word inverse means to undo something, the word opposite doesn't necessarily mean to undo anything. Okay, so when you want to take the inverse, you want to try and undo something right there. Okay, so let's figure out the way that we write the inverse is like this. We say f inverse of x. Okay, so this is written as f inverse of x. And you see that. Yeah, that is a -1, but that does not necessarily mean like 1 divided by that term. When you see it, that's read f inverse of x. Okay, so think about it like this. If the input to my function is Bob, the output would be $50. You guys agree with that? So that means that the inverse needs to be that if I put in $50, then out comes Bob. If you think of it as a metaphorical vending machine, right? Sally. Yeah, terrible wise, right? So this right here would represent the inverse of x. So the question I have to you is, what did I do? I did something very, very simple. What was it? You guys say flip. What did I flip? Ah, yes. All that I did was I switched the domain with the range. To find what? And how do we say the inverse? F inverse of x. Okay? So there you go. That's our first idea of how to do it, what this is, right? All right. I would like to give you another example here. If I give you this. 2, 4, 6, 3, and 7, 1. Okay. This is a set of ordered pairs. Who remembers the name of a set of ordered pairs we used for a function? It starts with an R. Yeah. Yes, this is a relation, right? Okay. In this relation, can you tell me the domain? What would it be? 2, 6, and 7. What would the range be? It would be 4, 3, and then 1. Okay. And this, would you agree or disagree that this represents a function, f of x? Yes or no? Yes, it does, right? How come? Because every input has a unique output, just like you said in the beginning. Okay. Could you please then find for me, could you find f inverse of x and write it as a relation? All right, who's got it for me? Yeah, Jonah. Yeah, go ahead and give me the relation for f inverse of x. 4, 2, 3, 6, and 1, 7. So how did you get that? You switched what? I switched to 4, which is under the range, which is under the domain. Okay, so you just switched every input for the domain for every output for the range, just vice versa, and found the inverse of that function. We're feeling pretty good about how to find the inverse of a function and a relation for now? Okay, we dived into it deeper, but just as the basic concept. All right, I'd like to introduce the idea of a one-to-one function. You may also notice that on the left-hand side, I'm sort of writing some key questions down for you as I go. Some things that I think you should be able to answer by the time the lesson's over. Right, so number one, this one up here was, I don't know if you saw it, what does f negative 1 of x mean? So hopefully you guys can answer that question, f inverse of x, yeah. Here's the next question I have, what is a one-to-one function? So I'm about to tell you what that is right now. A one-to-one function is a subcategory of functions themselves. So first we teach you polynomials, then we teach you functions, then we sort of branch out into different types of functions. And one of those types of functions is a one-to-one function. So what does it mean? What is it? So here you go. And do you remember me telling you that the book does a terrible job of telling you what a function is? And so I gave you my own silly definition, like take some stuff, do some stuff, to it, get some other stuff. Remember that definition, right? Well, it's the same thing with one-to-one function. I don't think they do a very good job with that one, so I break it up into my own little silly definition here, which is like a 3-step process. So step number 1, it's an if statement. If f of x is a function to begin with, and step 2, if f inverse of x is also a function, then 3, then f of x is what's known as a one-to-one function. Okay, so these things are if-then statements, all right? So it's a if 1 and if 2, then you get 3. All right? So if, number 1, f of x is a function to begin with, 2, and f inverse is also a function, then you are dealing with what's known as a one-to-one function. Does that make sense for you? Yeah. All right, good. So let me give you some examples with this. Like that. All right, I have 3 things set up here. I have example A, B, and C. And what I'm going to do is I'm going to give you some pictures. So I'm going to give you 2 pictures, 2 for each one here. So go ahead and set this up. Okay, in the first picture, the first box is always going to represent domain, and the second box is going to be range. Domain and range, domain and range. In the first picture, give yourself 3 dots, like a dice, or I mean a domino, sorry. A dice. And then give yourself 3 dots in the range too. In the second picture, give yourself 3 dots on the domain and 2 dots in the range. In the third picture, give yourself 2 dots in the domain and 3 dots in the range. Alright, and here's how the pictures go. In picture A, you've got this, this, and this. That's picture A. Picture B, you've got this. That one goes there. That one goes there. That one goes there. And then picture C, you have this. That one goes there. That one goes there. And that one goes there. Here's what I'd like you to do. Number 1, determine if the picture represents a function or not. If it does represent a function, then also determine if it represents a one-to-one function. So, directions. Number 1, figure out if these pictures represent a function. If it is, figure out if it also represents a one-to-one. If it isn't, say not and say why. Is this a function, yes or no? Yes. Yes, f of x is a function. Okay, now, how do you tell if the inverse is also a function? Is there something that you can do maybe on the graph that could help you determine if it was a function, if the inverse was? Yes? Put a little arrow on the other side of it. Yeah, could I draw like this picture? That one, and then that one, and then that one? So looking at the red, is that what you meant by that?
I meant you just put like another thing on the other side.
Oh. Alright, looking at my red graph now, does my red graph also represent a function? Yes, and it also represents the inverse. So number 2 would be like f inverse of x is also a function, right? Okay, so that would tell you what? Yes, that would tell you that f of x is 1 to 1. Because 1, we have a function to begin with. 2, we have an inverse that's also a function, therefore it's 1 to 1. Okay, part B, who's got it? Yes. Ethan.
Well, it starts off originally being a function.
Okay, so f of x is a function.
But the inverse is not.
2, but f inverse of x is not a function. And you could see that because this, if I draw a different one, this one would go there, and this one would go there. You guys see the outputs there? And then this one would go back to that one. So what does that tell you? It's not what? 1 to 1. Right? It is a function, but it's not 1 to 1. So as you can see, right, it is possible for a function to be both, not at the same time, but there are different types of functions out there, right? Some are just regular, and some have an inverse, but sometimes those inverses are not functions themselves, so they're not classified as 1 to 1. Okay, then part C. What's going on with part C? Yeah, this thing's just not a function to begin with, right? How come? Yeah, because of that part right there. Very good. All right, cool. Seems like you got that down. Okay, cool. I want to review. I'd like to review 2 things, 2 tests for you. All right, the first one is, you may recall, the vertical line test. So I'll call that the VLT, the vertical line test. What does that tell you? Does anybody remember what the vertical line test tells you? Yeah, it tells you if the graph of f of x is a function. All right. Did you know that there's a horizontal line test as well? What? Okay. Okay, can you guys think you can put it all together? Everything that we're studying right now? What do you think the horizontal line test tells you? Inverse and if it's 1 to 1. Tells you if f of x is 1 to 1. There you go. So I wrote a little key question on the side. So what does the HLT tell you? And I'll that stands for this one here. HLT, horizontal line test. So I've got two examples here. Real quick, I'll sketch them out. Okay. Here's the first one. Here's the second one. I'll give you f of x is equal to x squared. Okay, what parent graph is f of x equals x squared? Yeah, it's a parabola, right? So 0, 0, 1, 1, and then 2, comma 4. So it looks like this, right? All right, great. So, number 1, is that a function, yes or no? Yes, it passes the vertical line test. So number 2, does it pass a horizontal line test? So that implies a function, but it does not pass the horizontal line test, so it's not 1 to 1. All right, you guys got that part? All right, let me give you one that actually is, okay, and you see the difference. Take f of x equals x cubed. What's the x cubed one? Yeah, the backwards s. You got it. So the backwards s kind of looks like this, right? 0, 0, 1, comma 1, negative 1, comma 1. It's more like that. All right. So this passes both, doesn't it? Passes the VLT and it passes the HLT. So that implies that this is a 1-to-1 function. So, not every single function out there is 1 to 1, right? So, guiding question right there. What does the HLT tell you? Make sure you answer that question. All right, there's only one more box to go. You guys ready to do it? Okay, last box. Please draw this diagram on your page. Do I move up a little bit for you? Okay, sorry about that. Yeah, I think you go about 5 or 6 in each direction. Okay, everybody have their graph? All right, I want to put 3 points on the graph. These are the 3 points I want you to put on there. -2, -2. So put that point on the graph and label it. -2, -2. -1, 1. -1, comma 1. And 4, comma 3. All right, and then take your graph, or take your points and sort of hook them together like that. All right, would you say that that graph represents a function, yes or no? Okay, why does it represent a function? Passes what? Passes the vertical line test. Okay, great. Now, go back all the way up to the very first box. How did we come up with the inverse to that function? What did we do? We switched what? The range and the domain. Now look at the second box. The second box was a relation, had ordered pairs in it. How did we come up with the inverse for that? We switched the domain and the range. So, taking our 3 points here, what is the input and the output for my top point and then column in quadrant 1? What would it be? 4, comma 3, right? So how would I get the inverse to this? I just switch them, 3, comma 4. So go ahead and switch them and plot that point on the graph. 3, comma 4. All right. And in fact, why don't we switch all of them? So we'll switch this one. And instead of -1, 1, I'll have what? 1, -1. Ooh. Oh, somebody's seeing something here. And then if I switch these two, well, I'll just get -2 and then -2 again, right? Now go ahead and connect those dots. Hey, check that out. Fish. Made a fish. We made a fish. All right. But take a look at the guiding question I have for you. Does anyone notice anything about this particular graph?
Oh, it goes in the middle of the...
Very, very good. Yeah. So, check it out. Here's the deal, right? If you take the line y equals x, which is the diagonal, yeah, you get the line y equals x here. The line y equals x is the line that any graph and its inverse will be reflected over. Pretty cool, huh? Mm-hmm. So you'll notice that each of these points is exactly the same distance away from that line right there. There you go, made a little fish. Well, it's the same, right? 0 distance away from the line. So, any function f of x and its inverse, f inverse of x, will be reflected over the line y equals x. Pretty cool, huh? Yeah, I didn't know that, huh? So there you go. That's the third question, right? How is line f of x important for graphing inverse functions?